go over the review for Module 1. So the first question that we have is number 17. So let's look at number 17. I'm going to look at 16 first. So 16 says negative 4, 5. That's where P is. Negative 4, 5. Put a little mark on that. How do I get to P prime? Well, to get to P prime, I could just count. 1, 2, 3, 4, 5, 6. Is that right? 1, 2, 3, 4, 5, 6. And down 1. So I went to the left 6, and I went down 1. Going to the right 6, is that addition or subtraction? That's addition. And going down is subtraction. So I know we didn't do this much. It was kind of like the piece that I didn't like in the examples that we were doing. But I could take negative 4, and I could add how much? 6, and I could take 5, and I could subtract 1. And I'm going to do that for each one of these. I would add 6 and subtract 1. Add 6 and subtract 1. The other way to do that would be just to find where P prime is. All right, so this one actually said describe. This won't be on the test, but I just wanted to go over it with you guys. This is something more like what would be on the test. Describe the algebraic rule for triangle DEF. So DEF is this really skinny guy, right? Kind of scrunched. And the image of D prime E prime EF is right here. So to come up with that rule, I should probably see what's happening to DEF in comparison to D prime, E prime, F prime. So where is D? Somebody tell me. Negative 2, 0. And E? Negative 4, negative 1. And F? 2, negative 1. Thank you. Somebody want to give me D prime? Negative 1, 0. And E? 1, negative what? 3? Is it negative 3? 1, 2, 3. Yeah. And E would be, I'm sorry, F prime? 1, oh, that's F. F is 1, negative 3. So what's E? Negative 2, negative 3. Thank you. All right, let's talk about what happened from negative 2 to negative 1. How do I get from negative 2 to negative 1? I could add 1. What about from negative 4 to negative 2? Does that work, adding 1? No, so addition or subtraction isn't going to work, so let's try multiplication or division. How can I get from negative 2 to negative 1 using multiplication or division? Divide, right? If you can't multiply to get from 2 to 1, then you'd have to go from this side and go, well, how do I get from 1 to 2? I would multiply, right? Multiply by what? Negative 1 times what makes negative 2? 2. So if I multiply this direction by 2, then when I divide, what would I do on this direction? By 2, right? 1/2. All right, so the rule for this one is I'm going to cut x in half. How do I get from 0 to 0? I don't know, but I know I'm not going to have to add or subtract because then it would be different, right? So it must be multiply or divide. So how do I get from negative 1 to negative 3? Multiply by 3. That's a little bit easier. Everybody understand the rule and how to get it? Questions on that one? No? All right, let's move on to number 19. All right, let's look at 18. What's the transformation from 18 by just looking at it? What type of transformation is this? It's a reflection. It's a reflection over what? Good. It's a reflection over y-axis. Y stays the same, so it's reflecting over y. If x stayed the same, it would be reflecting over x. All right, what about this one? If I add 9 to x and add 2 to y. Good. This is the translation. It's picking it up and moving it over 9 and up 2. That would be sliding it, right? Taking it from 1 and just picking up and moving. Is that rigid motion or non-rigid? That's rigid. Perfect. Questions on either of those? Moving on to 20. Number 20, draw the image of the figure under the given transformation. So I like to write my little arrows here. So in my transformation, I'm going to go to the right. How many? Uh-oh, I just lost power on here. Give me 1 second. My Moby lost power. All right, anytime now. There we go. Come on, pen. Wow, that took a long time to connect. Sorry about that. Okay. So if I am adding 4, I'm going to the right 4. And if it says y minus 5, what am I going to do on the y-axis? I'm going to go down 5. So I always like to start on the actual pre-image, and I like to mark when I've done a vertice. A vertice is one of these corners, right? So I'm going to mark this, and I'm going to say, okay, I'm going to go over 4 and down 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Now I'm going to do this one. 1, 2, 3, 4. 1, 2, 3, 4, 5. Now I'm going to do this one. 1, 2, 3, 4. 1, 2, 3, 4, 5. And this one. 1, 2, 3, 4. 1, 2, 3, 4, 5. Does that look like the image? Good. All right, number 21, a reflection across the y-axis. Now, traditionally how I showed you and how the book shows you is to, let's say this is A, and A is at negative 1, 2, 3, positive 2. Negative 3, positive 2. And the rule says to reflect over the y-axis. Give me 1 second. I'm going to use this. So what's the rule for reflecting over the y-axis? What changes? The x changes, or becomes the opposite. So in order to satisfy this rule, A prime would have to be positive 3, 2. Good. So I would go over to 1, 2, 3, 1, 2. Want to see an easy way to do it? If I'm reflecting, some of you have already figured it out. If I'm reflecting over the y-axis, then couldn't I just count? If I'm at A and it takes me 1, 2, 3 moves to get to the y, wouldn't I have to go 3 more? This one, I'm already on the y. I move 0, so I stay 0. And this one moves 1, 2, 3, 4. Oops, don't want to mark it because then it would be green. 1, 2, 3, 4. So I should go another 4. 1, 2, 3, 4. Question? A little easier? All right, fantastic. So there's 21, 22. Okay, so your equality was like over here, but this is the way it should have been on your paper. Okay? All right, so let's look at this. This says I have Hj equaling Hi plus Ij. Well, Hj is this whole thing right here, correct? And they've actually given you that it equals 7x minus 3. So that's that. Then we have Hi. Well, Hi is from here to here, correct? And they've already given us that as well. That one is 2x plus 6. And then they also say plus Ij. Well, Ij is here and here. Yes? From here, oops, it didn't change color. From here to here. Okay, so saying that segment HG, or the measure of HG, is equal to Hi plus Ij, what postulate is that? Segment addition postulate tells me that. Look, I'm going to cheat or be resourceful. Segment addition postulate. I'm going to put a little mark on that one. Use that one. I'm just going to cover it up. That way we don't even have to look at it. That one's gone. Okay, so now to get from this statement down to 7x minus 3 equals 2x plus 6 plus 3x minus 3. Okay, a lot there. First of all, where did they get 7x minus 3 from? They substituted Hj. Good, so this is this. You guys are already on it. And this one is the one in blue, and this one is the one in green. And you guys already said it for me. It is substitution po, right? Cover that one up. All right, now to get from here to here, what do we have to do? I have 7x minus 3, so same thing on this side of the equation. We had to add, so which one do you think it is? Okay, so it's a little confusing. You had to add them together, but addition property of equality doesn't mean add together. Addition property of equality means add to each side of the equation. Equality, add equally to both sides. Did we add equally to both sides? No, we did not. So what? We had to simplify. I know I heard it, but I was ignoring you because I didn't want to know it yet. Okay, simplify. Because I heard people saying addition property of equality, so I didn't want to, give it up too soon. All right, so simplify. That one's gone. Now, to get from this one to this one, what'd you have to do? Add 3 to both sides. So that would be addition property of equality. What about to get from this one to this one? From here to here? Subtraction. Jumping the gun, right? And then finally, division. Not so hard now? Are we hitting the ones that you guys wanted to see too? Good. It usually works out that way. Questions? All right, so that was 22. Let's do 23. All right, for any integer n cubed is going to have to be greater than 0. It asks me to come up with a counterexample that proves that wrong. So what could I substitute for n to prove that n cubed is greater than 0? I could put in 0. See, I put in -1, but you guys are smart. You put in 0, and that was easier, huh? So if I say that n equals 0, if I put in 0 cubed, is 0 cubed greater than 0? No. This is not true. Questions? 24. Each angle in a right triangle has a different measure. If I measure all of the angles inside of a triangle, what would they all equal? All angles inside of a triangle are equal to 180 degrees. Okay? So if I were to take a right triangle, and somebody pointed out that this is kind of written kind of poorly. If I were to take a right triangle is a special triangle. A right triangle already has a 90-degree angle, right? So if I start with 180 degrees and I subtract 90 degrees, how many am I left over? I'm left with 90. So that means, is there such a thing as having these angles be the same if they have to total 90 degrees? No? What? It was, huh? Each angle in a right triangle has a different measure. Okay, so this is saying that there's no way that these two angles could be the same. And we're going to come up with a conjecture to prove that false. I'm saying that there is such a thing as these two angles being the same. Now, I heard from somebody in the last class that it sounded like all three of the angles have to be 90 degrees. That's not what this is saying. It's saying that the ones other than the right angle. It's not worded very well, is it? There we go. That would be a 45, 45, 90. And these are not subtraction signs, these are hyphens. It's a 45, 45, 90. Whenever you see something like that, you know that they're talking about measures of a triangle. What's another famous measure for a triangle? 30, 60, 90. Now, that one has different measures, right, other than that one's different, but this one is the same. So there's our counter example. A 45, 45, 90, 45, 45 are the same. Make sense now? Okay, better. What did you guys get for 25? Just explain it to me. Good. One number times the previous number, right? If you want the next number, you take the number times the previous, and that gets you the next one. Good. Did you guys do okay with these? Yeah. This is the hypothesis. This is the conclusion. Good. That's the law of detachment. Okay? Alrighty. Are we already to here? Let's see, we did 24. So now we're at 28, 28, 29, 30. All right, 28. So find the measure of RQK. RQK is right here. RQK. So this is what I'm looking for right here. If the measure of RQK is 19x. Okay, so they told me, they're giving me a little more information, 19x. I may not know what 19x is, so they must want me to find x. So I can substitute it back in and then find it, right? That's what I'm guessing. Let's continue. So this is 19x. Then we have KQP, KQP, and how much is KQP? 75, it says it right there. And finally, they gave us the measure of RQP. So RQP is this angle here, which it looks like it's almost, they almost look like, what do we call when we have two angles and they make 180 degrees? They're supplementary angles, correct, and they form a linear pair. Who said it? Good job. They form a linear pair. Did you say it too? I'm sorry. Linear pair. They form a linear pair. But this isn't a linear pair. Why? You know, I shouldn't say that. I shouldn't say it's a linear pair. What? It's not, but you can't assume just from the picture. So at the end, would I be able to tell if it's a linear pair? How? Yeah. Once I solve for x and I add the two angles up together, they'd have to equal what? They'd have to equal 180. So you guys, that's really important in geometry. You can't just look at the picture and assume. You've got to show proof. And proof would be adding the two angles together. Okay, that being said, that's not even part of the problem, right? Just wanted to put that on a side note. So, I'm trying to find 19x. I'm trying to find RQK. I've got this angle, and they told me that the really big angle is 34x. What postulate could I use to solve? Is it a segment, though? Are we talking segments? We're talking angles. What's that one called? Angle addition postulate, right? So how could I use angle addition postulate? How could I use angle addition postulate? I'm going to add green and blue, and it's going to equal red. So let's add blue, which is 19x, and let's do it over here. 19x plus green, 75, equals 34x. So if I were to subtract 75 from both sides, what would I get? Sorry, jumping the gun again. Subtract 19x from both sides, and what do I get? 15x. If I divide both sides by 15, what am I going to get? 5. What am I going to do with 5? Substitute it back in. So now, if this says 19x, I can use 5 to say, what's 19 times 5? 95? Huh. You know how you could do that really quick in your head? I may not know what 19 fives are, but I know what... Oh, that's one way to do it. 10 fives and 9 fives. I would do 25. How much are 25? What's 25? 100. Take away 1 5 because I don't need 20. I only need 19. How do you take 5 away from 100? Subtract 5. It's 95. Right? Way to do it in your head? That's mental math. Okay. So our answer is, let's go back and make sure we answered the question. Find the measure of RQK. Have we found RQK? RQK is 95 degrees. Number 29. This is poorly written. It confused me at first. Oh, I don't like that one. Let's do another one. Must be pretty, right? So we'll say that. I'm going to stretch it. I'll put it right here. Is that better? Yeah. Now it shows that that's the whole segment, correct? Yeah. All right. So this one is saying find EC. So E all the way across C. I'm finding EC. Which postulate could I use to solve this one? Segment addition postulate. Yes, ma'am. Yes. So, segment addition postulate. So, segment addition postulate says if I take x plus 4, which is this one, let's back this across here. Let me change the color to blue. So x plus 4, which is right there, right, is going to equal what? So let's make this one 2x minus 11. That's ED, even though it's bigger than the segment is, right? Does everybody agree that 2x minus 11 represents the measure of ED? Okay, so that would be... Do I really need these parentheses I keep using? Why am I using them? To help what? Help organ, just so you can see it. It's like saying, hey, check this out, I've got this measure, and hey, check this out, I got this measure. That's what I'm using the parentheses for, just to make it neat. So from here to here, how much is that? 9. So the red one plus the green one is going to equal the blue one. Now what? Not bad. Let's solve. Let's go collecting like terms. So I've got a 2x. Do I have any more x's over here? No. How much is negative 11 and a positive 9? 2. So I could take an x off of both sides, right? If I took an x off of both sides, I'd be left with 4 equals how many x's? 1x minus 2. Take negative 2 off both sides, what do you end up with? 6. Am I done? Am I done? Let's go back and ask ourselves. It says find EC. Did I find EC as EC 6? I've got to go back and substitute, right? So I've got to take this one and consider substituting. So x plus 4 is equal to 6 plus 4, which equals 10. Questions? Last one, number 30. Points A, B, and C are collinear. What does collinear mean? Same line, right? Same line, collinear. Gentlemen, am I interrupting? Are you sure? Okay. So A, B, and C are collinear. Point B is in between A and C. I'm going to draw that real quick. Let's see. So I've got a line, and I've got A, and I've got C, and B is somewhere in between. Doesn't have to be the middle. If it was the middle, what would they tell me? It was the midpoint, exactly. So I don't know where it is. It could be anywhere, right? Hey, we didn't go back and make sure that, is this a linear pair? Is 95 and 75 180? How much is it? 170. So it's not, okay. All right, find x if BC equals x minus 3. So here's BC. We'll make that one blue. BC is x minus 3. AC is 14. That's the whole thing. AC is 14. That's what these lines mean. From the measure from here to here. And then AB is x plus 1. Which postulate am I going to use? Segment addition postulate. So I'm going to add x plus 1. Got to change my color. X plus 1 plus x minus 3 equals 14. Let's combine like terms. How many x's do I have over here? 2 x's. How much is negative 3 and 1? Good job. And I add 2 to both sides. What do I get? So x equals 8. Did I find what I needed? Solve for x. I found it. We're good. All right, great job, guys. Does anybody have any other questions on here? We got 5 minutes. Anything I didn't cover? 3 and 4. That doesn't mean pack up, right? You could not use a compass. You will not have a compass tomorrow to use. That is a very good question. Why not? Because this is why it says use the distance formula. You guys didn't ask me about 1 and 2. You asked me about 3. This is going to be Fridays. This would be on Fridays. Yes. You guys have a test on Thursday. There's a reason for that, right? Because I don't want you using a compass for this. So everything without compasses and protractors is tomorrow. Everything with compasses and protractors is on Friday. Okay? 3 and 4. So it asks me to find if CD and EF are what? The same length, using distance formula. So I would have to find CD. So distance equals the square root of the rise squared plus the run squared. So what's the rise squared of CD? 1, 2, 3, 4. 4 squared. And the run squared is 1 squared. So how much is that? Square root of 17. What about EF? Square root. Where's E? 2 squared plus 3 squared. What's 2 squared plus 3 squared? 4 plus 9? 13. Are they the same distance? Nope. GH. What's the measure of GH? 2 squared plus what? Are you guys doing better at that? Yeah? Much better? How many of you took geometry last year and that was hard for you? Yeah? Is it better? Are we doing better? Yeah? Okay. So 16 plus 4 is 20. What about JK? One squared and 4 squared. We already did that one, right? That's 17. So are they the same length? Nope. So neither one of them have the same length. Anybody else? Go ahead and pack it up, guys. You did a good job.